Assalamualaikum everyone. Welcome to my presentation. Before I begin, let me introduce to myself. I am Sayyid Yaminur Rahman, Section B, ID 067, Department of Tripoli. So today I'm gonna discuss about electric AC circuit mesh analysis. So welcome to our exploration of AC circuit mesh analysis. We will delve into fundamentals of AC circuit and learn how to use mesh analysis to solve complex problems. By the end, we will understand the theory behind this powerful technique, how it's applied, and benefits it offers. Introduction to AC circuits. The first thing is alternating current. Here, in AC circuits, the current flows in sinusoidal pattern, changing direction periodically. It makes them different from direct current DC circuit, where current flows in one direction. Secondly, components. AC circuit includes components like resistor, capacitors, and inductors which interact with the changing current in a specific way. Third one is mesh analysis concept. So the first thing is we need to identify the meshes. Identify independent closed loops in your circuit, each containing one or more circuit components. If we look in the picture, we see that this is a loop 1 and this is loop 2, and these are resistor which are components. Secondly, SN currents. So SN a current variable to each mesh representing the direction of current flow. Here the direction of current flow. And third one is apply KVL. Apply Kirchhoff voltage law to each mesh, creating a system of equation. Kirchhoff voltage law. Sum of voltages. KVL states that the sum of all voltages drops around any closed loop in a circuit must equal zero. This is based on a principle of energy conversion. Voltage drops. Voltage drops occur across individual components in a circuit due to the current flowing through them. These drops are calculated using Ohm's law. If we want to find out the equivalent of resistance, the formula is Req is equals to Ra plus Rb, and here I is equals to V by R. Formatting mesh equations. Step 1. For each mesh, write an equation that sums the voltage drops across components. Remember to consider the direction of the current flow. Step 2. If a component is shared by multiple meshes, the current through it is the sum or difference of mesh current. Step 3. The system of mesh equations can then be solved to find the unknown current. If we look into the picture, here is some equations of this circuit. Here is the main circuit. If we do the mesh analysis in this circuit, here is mesh 1 which is current 1, then it is mesh 2, mesh 3 and mesh 4. The equation is look like this. Solving mesh equations. The first method is matrix method. For complex circuit with multiple meshes, the matrix method is often used. It involves representing the equations in matrix forms. Second one is substitution. Solving for one mesh current in terms of other and substituting into the remaining equations can simplify the system. Applying mesh analysis. The first one is identify meshes. First, identify the independent closed loops in your circuit. In this picture, if we look, uh, we will see that this is a closed loop, and here is I1 is loop 1 or mesh 1, and here is another a closed loop which is defined as I2. Second one is SN currents. Assign a current variable to each mesh indicate the direction of current flow. Here is the direction of current flow. Apply KVL. Write a KVL equation for each mesh and taking into account shared components. And last one is solve equation. Solve the system of mesh equations using methods like matrix or substitution. Problem solving. Use mesh analysis to determine current I0 in the circuit. If we look in the circuit, here is a circuit and we need to find the I naught current. So the first thing we need to do is convert the voltage. Here is voltage 1 V1 and here is voltage 2 V2. We need to convert them into complex form and we will find the complex form is V1 is this and the V2 is this. So here is loop 1. For loop 1 we need to write this equation that is 50 minus 86j plus 80i minus j40 into i1 minus i2 because this j40 impedance shared i1 and i2 both currents, and we will finally get the equation 1. For loop 2 we will get this equation minus j40 plus j60 minus j40 into i2 and j40 i1 plus j40 i3 is equals to 0. This is equation 2, and in the same way we will get this equation 3, and here I2 is equals to I naught. By solving equation 1, 2 and 3 we get I2 is equal, that is equal 2.17 degree 61.4, which is I naught. So we can easily say that the I1's I naught current is 2.17 and the degree is 61.4. Advantage of mesh analysis. First one is simplified analysis. Reduce the number of equations compared to nodal analysis. Organized approach provides a systematic way to analyze the complex circuits. Intuitive, easy to visualize and understand for beginners. Limitations and considerations. 1. Inconvenient for current sources. The method struggles with independent or dependent current sources because it primarily focuses on voltage and requires adjustment. Number 2. Not suitable for circuits with many loops. For circuits with a large number of loops, the system of equations becomes large and complex, making the method insufficient. Number 3. Less intuitive for voltage calculation. While loop analysis focuses on calculating currents in loops, determining node voltages requires additional steps. Thank you everyone to stay tuned with me.